Bicycle component systems have tended to lag equivalent technologies applied to the automotive sector. This is particularly the case with the application of bicycle braking systems. Braking on slippery surfaces or in emergency situations is potentially dangerous. During full or even partial braking, it may no longer be possible to fully transfer the braking force onto the road. The braking force is too excessive and the wheels lock up. The locked wheels no longer provide any grip on the road and are almost incapable of transferring any cornering force. This has dangerous consequences. The bike becomes unsteerable. After carrying out research, it became apparent that ABS technologies that have been implemented in other forms of transport could be adapted to work on bicycles, in order to guarantee stable braking in emergency situations. The final design comprises of some custom-built parts and several bought-in components. The sensor and spoke attaching magnets which convert the motion of the bicycle wheel into a digital signal. The ECU which uses these signals to monitor the rate of wheel deceleration, and actuates the hydraulic modulation unit in the event of a wheel lock. The hydraulic modulation unit, which reduces the pressure at the caliper so the wheel is braked less heavily. In this design, the pulse ring that can be found in standard car ABS systems has been replaced by magnets which attach to the spokes of the wheel. The magnetic dependent resistors in the sensor's electronics detect a rotating magnetic field as the wheel rotates. Electronics in the sensor convert the resulting sinusoidal signal into a digital signal. During normal braking, no current will flow from the ECU to the hydraulic unit. However, if the wheel center detects severe deceleration, the ECU sends current. This energizes the solenoid valve, isolating the master cylinder from the brake circuit. This keeps the braking pressure and the caliper constant. The ECU then sends a current to the solenoid, which actuates a piston, generating more space in the isolated hydraulic circuit, reducing the pressure of the caliper and allowing the wheel to accelerate again. The ECU then stops sending current to the hydraulic unit, allowing the brakes to be reapplied. This cycle is repeated several times per second.